Hello and welcome. In this video I'm going to complete a series of tasks for BGP on OcNOS devices. The task says I should configure OcNOS routers in AS200 to send community attributes to their peers. First of all, you should know that this is already done by default. OcNOS devices send communities, both extended and standard attributes communities to other routers by default. Any other IBGP neighbor or eBGP neighbor is going to receive these communities. So for this, I'm just going to show you something. On router 10, for example, I'm going to say show IP BGP neighbor, let's say for example 8888, and hit enter. So in this line, it says that community attributes sent to this neighbor, both. This means that standard and extended attributes are community attributes are sent to this neighbor. So this part of the task is already done for us. Next, it says add a secondary IP address of 10.10.10.11 to loopback interface on router 10. So if I just show you the running configuration of interface loopback, you can see that I have already added this to interface loopback. And the last part of the task says you should advertise it to BGP, but other ASs should not receive this. This should stay only in AS200. Okay, I'm going to do this, but after that, I'm going to explain what is going to happen. So at this time, I'm not going to explain the topology. What I'm going to do is to just say configure terminal, router BGP 200, address family IPv4 unicast, and then I'm going to say network 10.10.10.11/32. So I have advertised it into BGP, and I'm going to commit this. With this, what I'm going to do is to go to one of the routers, let's say router 8, which is in the same autonomous system, and I'm going to say show IP BGP 10. Oh, let's say just show IP BGP. Now you can see that 10.10.10.11 is here from router 10, and also router 11 is another route reflector in the same cluster as router 10. Now, if I just go to here, now I'm going to explain the topology so that you can figure out what is happening in our network. Specifically, what we are interested in is AS200, AS300, and AS400 in our topology. So I'm going to zoom in a little bit. In here, what you see is router 10 is here, which is advertised the prefix. The prefix goes to router 8, 9, and also 11. Router 11 is going to send it to router 16. Based on our previous tasks, I have configured Autonomous System 300 as an MPLS network. And in this network, I have router 16 and 15 as let's say route reflector. So this is a route reflector. This is a route reflector, and let me just go with this. This is a route reflector, which means that inside this MPLS network, everything is going to be transparent to my neighbor. This route is going to be passed through this to Autonomous System 400, which is another branch of 200, and router 14 should see that 10.10.10.11 in here. If I want to see it inside my MPLS network, I can use the VRF extension. So let's just see that router 14 is receiving this or not. So on router 14, if I say show IP BGP, you can see that 10.10.10.11 is for sure here. Okay, the requirement says it should not leave Autonomous System 200. So what I'm going to do is to assign an attribute, a community attribute, to this specific prefix so that it doesn't leave the autonomous system. So for that, I'm going to go to router 10, and I'm going to say, okay, network 10.10.10.11, but I'm going to assign it a route map. And the route map says to no other AS. And then hit enter. Okay, this route map doesn't exist. I have to create it. So what I'm going to do is to say route map to no other AS, and in the first sequence, which is permit 10, I'm just going to set a community value of one of these. So the community value could be configured with number, with a newer format or older format. But there are some of the well-known attributes which are interesting, specifically these three. Local AS means that it should stay in the same AS that I am, should not leave. This is exactly what I'm trying to use. So I'm going to add it here. No advertise says, okay, this is just for you, my neighbor. No other router whatsoever. Whether other routers are in my autonomous system or in another autonomous system, I don't care. You and you only are going to use this prefix. No export says, okay, I'm sending this to you as my eBGP neighbor. You should keep it for your autonomous system. No other autonomous system should receive this. So this is a prefix that I'm sending to another autonomous system, but other autonomous system should not send it to any other neighboring autonomous system. So local AS is going to be selected for this and hit enter. So I'm going to commit this. I'm going to clear IP, BGP, any inbound and outbound, but outbound is important for me in this case. If I go back to router 8, I can see this prefix is still in here. And specifically, I'm going to show you the community value, which is set for that. You can see that it says now this match, this is marked with community of local AS. And I'm receiving this from 10 and 11 because 11 is another route reflector in my network in the same cluster list with 10. Okay. Now let's go back to router 14, which is down here in another AS, but the cluster, this is going to be another branch of my network. So if I just go to here, we already have it, but if I just check it, you can see that this is withdrawn. We don't have it anymore. So local AS means that it should not leave my autonomous system. No export means that I am sending this to another autonomous system. That autonomous system should not send it to another autonomous system. And no advertise means that I'm sending it just to you and you only. You should not send it to anybody else. So that is what we just configured. So this route map actually was configured on the on the network itself. What if I configure it on a neighbor? So I'm going to just examine this one. So I'm just going to say router BGP 200, address family IPv4 unicast, no network this, commit it. Then I'm going to say network this without the route map. I'm just sending it to router, let's say 11. Okay. So I'm going to say neighbor 11, 11, 11, 11. I'm going to use this route map, which is no other AS, and I'm going to send it outbound. Now the thing is, in this route map, I have no match. I need to have a match for this, because if I do not match, every prefix is going to be like this. So let's go to this route map. Permit 10. Route map, of course, without out. Route map permit 10. I'm going to say match. And I'm going to use a prefix list. So I'm going to say match IP address prefix list. And the prefix list is going to be, let's say, 10, 10, 10, 11. This is the prefix list that I'm going to create. And hit enter. So this is going to be matched. And for the rest, because I don't really want to, stop them from being, deny them from being advertised. So what I'm going to do is to say route map permit 20 without anything. So let's create that prefix list because we don't have it. So I'm going to say exit IP prefix list, and the name is going to be 10, 10, 10, 11. I'm going to say sequence number 5. So under this. So I'm going to say sequence number 5. I can just go with a sequence number. And after that, I'm going to say permit. And specifically, I'm going to say 10.10.10.11 slash 32. And because this is a slash 32, I'm not going to have anything like greater than, less than, or anything else. So I'm going to commit this configuration. Okay, so let me show you what is happening here. First of all, I'm going to say do clear IPBGP any out and also in. Inbound is not so necessary, but just let's see. Let's check what we did. If I say show run prefix list, this is a prefix list that I just created. Only one prefix is going to be selected. Others are not going to be matched. Show run route map. This is the route map that I created. In the first one, I matched this prefix, and then I added the community value of local AS. For the rest, I am just permitting everybody else. I have this just because I don't want to deny any of the other prefixes. And then show run router BGP. Now you can see that I have added that route map to router 11, which means that this is going to go to router 11. Router 11 is going to set this, and then router 11 is not going to send it to other routers. Now we are going to see what is going to happen, because router 11 is not supposed to send it out. Now if I just go to router 11, and I'm going to say OcNOS, I'm going to say show IPBGP. You can see that I have the prefix. And if I check it specifically, /32, it has the community value of local AS. But what about router 8 and 9? They have not actually received it directly from router 10. Are they going to receive it like this or without that? You can see that here, when I check that, this community value is set, but maybe that is not maybe, because this one is received from 11.11. The other one does not have any community value, so 10.10.10 has not sent any community value to router 8. The same is going to happen on router 9. So let's see what is going to happen. And of course, this one without community is the best one. So if I just go to router 14 and check this, on router 14, do I still have this prefix or not? You see that I am not receiving this. That is because what we have here is, and let me just start this router because I want to show you something. What I have is the adjacency between router 16 and 11 is so that router 11 is going to send the route with prefix to here. If I just go to router 11, I have only this, and this has the community value. What about router 1 in here? Is it going to receive because we saw that on router 8 here, we have this one as best without the community value. Is it going to send it to router 1 or not? Let's just open router 1. And this is going to come up in a second. And after that, I need to log in. And go to here, show IPBGP summary. This is going to take some time before the neighbor comes up, but it has already come up, so I can just say show IPBGP. You can see that I'm receiving 10.10.10.11 because router 8 is sending the one without community to me. Which means that, in this case, adding the route map to the prefix itself is going to be better and has a better predictability of the result than adding it to a specific neighbor. In some cases, of course, you have to specify a neighbor and add the route map to that neighbor for the result, but in this case, of course, adding it to the neighbor network is going to be better. So I'm going to go back to router 10, and what I'm going to do is to revert to the previous configuration. So what I'm going to say is to go to router BGP 200 under address family IPv4 unicast. I'm going to say no this. So and for the route map, of course, I'm going to create it one more time because I don't really want to have it like this. I only want to have it like this. So I'm going to say no route map this, and I'm going to commit the configuration for now. Then I'm going to go to there and say this one and just set community local AS, and under router BGP 200 under address family IPv4 unicast, I'm going to say network 10.10.10.11/32 is going to have this route map of to no other ASs. I'm going to commit this configuration. Now going to router 1 here, I can just check to see that this is going to be withdrawn. So if I just clear IPBGP any and then check this BGP routes after some time, of course, because I didn't say in or out, and you can see that 10.10.10.11 is no longer here. And on the other routers, of course, we are not going to see that. So with this, you can see configuring communities, and this task is completed. And I hope this has been informative for you, and see you in next videos.